Hey, today we're going to talk about neutralization reactions. A neutralization reaction is just when you add an Arrhenius acid and an Arrhenius base and you're left with salt and water. So Arrhenius acids have a low pH, Arrhenius bases have a high pH, and salt and water actually has a neutral pH. So basically what you're doing is you're kind of canceling out the low and the high with what is neutral. Okay? Now, refresh your memory for a moment. An Arrhenius acid has H+, Arrhenius base has OH-. The Arrhenius acids and Arrhenius bases are in tables K and L respectively. Mostly you'll be asked only on those Arrhenius acids and bases, but sometimes they might have additional ones. But usually anything that's on table K or table L are the only ones they're going to ask about in the regions. Now, let's do an easy one. A simple example, we're going to have an Arrhenius acid like HCl plus NaOH. Now, two things you got to pay attention to. Number one, Arrhenius acid and Arrhenius base. Because of their nature, you're going to be removing an H and an OH. And the H and the OH are going to form the water. Now in this example, I have one H and one OH, and that's going to form one water. Okay, and then I'm going to also have a salt in here that I'm going to add. Before I do that, let's look at this. 1H plus 1 OH is 1 water. We always want to make sure our H's and our OH's equal out, because if you have the same number of H's and the same number of OH's, you'll easily be able to determine how many waters you should have as a result. And it's going to make everything a lot easier. So make sure that you follow these steps. I would write this down because it's important. We have a regent coming up soon. Okay? 1 H, 1 OH yields 1 water. Now, so we have what's left over is I'm going to have the chloride negative and the sodium is positive. So my salt is actually going to be sodium chloride. Now this is easy to name and to write the formula, but just in case you didn't know, I know it's going to be sodium chloride. So I know it's going to be Na positive and Cl minus. Because this was H plus, this was OH minus, this has to be Na plus, this has to be Cl minus. When you have a 1-to-1 ratio, it's easy. They cancel each other out, so it would be written NaCl. So I would write NaCl. Gets a little bit trickier, and I'm going to go over one of those in a second. But if you look here, I have 1 sodium, 1 sodium, 1 chlorine, 1 chlorine, 1 H, 1 OH, that means 1 water. This first equation is balanced. Okay, next equation, slightly more complicated. We are going to add, first I'm going to need to balance this, so I'm going to add, let's see, we'll do H2SO4 plus KOH yields a salt plus my water. Now, first things first, let's look for our H's and our OH's. Here I have 2 H's, here I have 2 OH's. I got a problem. I need to have the H's and the OH's equal. There's 2 H's, 2 OH's. Now I have 2 OH's. And 2 H's and 2 OH's are going to give us 2 waters. Now what's left over? Let's get rid of our H's and our OH's. We have potassium, K, sulfate, SO4, sulfate, table E. So we're going to have potassium, which is a plus charge. We're going to have sulfate, which is a -2 charge, and I got that from table E. Now, remember how I told you to do this? This is the quantity, this is the charge. +1, -2. They both have to be equal to 2. Now this 2 times x, or 2 times 1 is 2. 1 times 2 is 2. So when I'm going to write my formula, it's going to be K2SO41. or simply K2SO4. When you're writing a neutralization reaction like this number on the salt, remember this is a salt, this number on the salt is always going to be 1, the way that I'm showing you here. There might be a couple of instances where this won't be 1, but you're never going to see that on the reagents. Okay? Now, let's move on to the most complicated type. It's really not that complicated though. So we're going to add H3PO4 for phosphoric acid, plus we're going to add calcium hydroxide. These are from table K and table L. Now that's going to give us a salt, and again plus my water. So first things first, H's and OH's, match them up. 3 H's, 2 OH's. This does not compute. 2 and 3 doesn't go into each other. They go into 6. Oh, let's make it worth 6. 2 times 3 is 6. That means this has to be a 3. 3 times 2 is 6. 6 H's, 6 OH's, 6 waters. Now our salt. I'm going to get rid of our OH because we don't care about that. We don't care about that right now. It's going to be calcium and phosphate. Now calcium is group 2, it's going to be +2, phosphate is -3, it's from table E. Figure this out. They both need to go into 6. 3 times 2 is 6, and 2 times 3 is 6. So the way I'm going to write it is Ca subscript PO4 subscript, or Ca3, I need brackets because I got a couple of competing subscripts, PO4 2. So calcium phosphate, Ca3PO4 2. There's another little trick here. If you notice, the number I put in front is going to be the subscript. The number that I put in front is going to be the subscript. Also, another little trick. Switch the numbers. Switch the numbers. There are practice problems right over here. Please, practice problems. I will see you guys. Peace.